We're at gotomath.com. Click on the calculus. Let's go down to the natural logarithmic functions. Now, up here in indefinite integration, we looked at actually some of these. So these are a little bit more advanced problems. We got to do a step or two more. Let's look at 1.1. Now, I throw a hint in here. Use long division to expand, then use the log rule. But we'll also need to do something else. So let's go ahead and write this one down. 5x squared plus 8x plus 5 over x squared plus 1 dx. Alright, so let's move over to the whiteboard. So remember, we call these indefinite integrals. So we have 5x squared plus 8x plus 5 over x squared plus 1 dx. So we look at this, and if you took the derivative of the bottom, you'd get 2x, and there's no way we could do that up here, right? So it doesn't look like we can use substitution at this point. But what we are going to do is expand this thing. We're going to use long division. So this might be a refresher. You can use probably synthetic division if you want, but I'm just going to use long division, even though synthetic division is faster. So we have x goes into 5x squared. We'll be left with a 5. Now, if you don't understand what that means, is think about this. Alright, so this x squared's down here on the bottom, this part's up here, and when you simplify this, you just get 5. Alright, little side work. Then what we're going to do is we're going to multiply 5 times x squared. Now, you notice we don't have a term with x to the first power in here, so we're just going to put a placeholder in here. Let's say 0x plus, so we don't multiply 5 times 1 and put it here. We say 5 times 1 and we put it here, right, which is 5. And then we go through subtract. So this plus will cancel out, and we'll put a minus sign right here. Alright, so 5x squared minus 5x squared, 0. 8x minus, really, 0x is just 8x. And then 5 minus 5 is 0. Now what we're going to do is we're going to take this piece here, 5, plus, and then go down here to this guy, 8x over x squared plus 1. Now we can rewrite all this dx. Let's put a parentheses around all this stuff here. Okay, so we're getting close now. Alright, I'm going to break this up into two separate integrals here. 5 dx plus the integral, and let's take this 8 and just bring it out front for right now. Dx. Okay. Alright. Well, this here should be pretty simple. Okay. That's just going to end up being 5x plus some constant, we'll say C1 there. Now this one over here, if you're looking at it going, oh, what are we going to do here? Well, if you take the derivative of the denominator, we end up with 2x, and you notice there's an x up here. So we could throw a 2 up here, but we'd have to throw 1/2 out front. So we know that this is going to be that u substitution type setup. So we're going to let u be the denominator, x squared plus 1, and then du is 2x dx. Well, we have an x and a dx, but we don't have 2, so that's okay. What we're going to end up doing is just take this 2 diagonally down, and we can now substitute the dx dx, and that'll be our substitution, half du. Right? Now, I'm going to go ahead and write write that 8 there still. Now remember what we do to the half, so you need to have watched the section on U substitution, or I think it was just called substitution or something. Bring that half out front. Right, this x and this dx is going to get replaced with the du. I already went ahead and took the that first part out, the coefficient. And I like to write 1 over something du, okay? And actually that something is u because this is all u right here. Right. So now we can go ahead and we're just rewriting that part there. Of course, this is just 4 right here, right? So what is the integral of 1 over u? Well, this is part of the log rule, and the integral of 1 over u is going to be, of course, this reduces down to a half of 8 is 4, the natural log of the absolute value of u, plus some other constant, alright? Now what we'll want to do here is get this thing back in terms of x, and so we have 5x, and we can combine both of our constants together, just add them together and you get another constant, plus 4 natural log of the absolute value, and u is x squared plus 1 plus c. Alright, so we just add both these constants and we get a constant. Alright, so there you go. Pretty simple. We had a few extra steps that time. Actually, I forgot to see 5x, 4 natural log. Making sure everything's good. 5x plus 4 natural log. Okay, it all looks good. All right. So I kind of help you out here. Use long division to expand, then use the log rule. But remember, we do have to use substitution too. All right, so come on by, check that out. We're at gotomath.com. Good luck.